Machine translation is one of those things that's just everywhere now. It's in the subtitles you watch, the messages you send to friends across the globe. It's become this totally essential, invisible part of our lives. But have you ever stopped to wonder how we got here? How this incredible power was even built? Well, that's the journey we're about to take. Seriously, it feels like actual magic, right? You just point your phone's camera at a menu in a language you don't speak, and bam, you know exactly what you're ordering. That one simple little act is the result of decades of intense, brain bending innovation. So let's pop the hood and see what's really going on inside this modern marvel. So let's get on the same page. What is machine translation, or MT? Well, at its core, MT is the big umbrella term for the whole field. It's not just one thing. It's a whole family of different technologies and approaches that have changed over the years, but they're all chasing the same really ambitious goal: getting accurate, fluent translation instantly, without a human needing to step. Okay, so here's our game plan. We're going to start at the very beginning, with the folks who first tried to teach machines how to speak human. Then we'll walk through the big eras, from systems built on super strict rules to a massive shift towards learning from data, and finally, we'll land in the AI revolution we're in right now. And along the way, we'll ask a really important question: how do we even know if a translation is any good? You can see the whole history right here. Our story kicks off way back in the 50s with these rigid, hand-built systems. Then, in the 90s, things start to get interesting as data enters the picture. That leads us right into the 2000s with statistical methods, which really powered the internet for a long time. And finally, that brings us to today, the age of neural machine translation. All right, first stop, rule-based machine translation. I want you to imagine trying to teach a computer a new language by just giving it a giant grammar textbook and a dictionary, and then telling it, okay, go have a conversation. That, in a nutshell, was the very first approach. You had actual linguists, human experts, who would painstakingly, manually write down every single grammar rule they could think of, every verb conjugation, every little exception, everything. They'd build this enormous, complicated rule book and feed it into a computer, basically hoping for the best. It was this massive effort to try and pin down the beautiful messiness of human language into code. And the process was super methodical, almost like a factory assembly line. First, the machine would analyze the grammar of the sentence it was given. Then it would transfer that grammatical structure over. And finally, it would generate the new sentence using the rulebook for the target language. Very logical, step by step, but also incredibly rigid. So what was the good and the bad? Well, the main strength was that it was transparent. If something went wrong, you could actually trace it back to a specific rule. But the limitations, oh man, they were huge. This is exactly why those early online translators sounded so bizarre, you know? They'd spit out these sentences that sounded like a confused robot trying to order a pizza. It just wasn't natural, because language is way too fluid for a simple rulebook. Yeah, that robotic output was pretty much a dead end. The whole rule-based idea was just too clunky to make real progress. So the field needed a new, totally radical idea. And in the 1990s, it finally arrived. The idea was simple: stop teaching the computer rules and just start showing it a ton of examples. The very first version of this new, data-driven idea was just brilliantly simple. It was all about translating by analogy. Instead of trying to learn abstract grammar rules, the computer would just look at how a human had translated something similar in the past and, well, basically copy that. Here's how it worked. You'd build a giant library of paired sentences, like an English sentence and its official French translation right next to it. When a new sentence came in, the system would find the closest matches in its library, grab the translated pieces it needed, and then kind of stitch them together to make a new sentence. It was a bit like creating a linguistic Frankenstein's monster, built from the parts of old translations. And you know what? It worked surprisingly well, if the system had seen something really similar before. But what happens if you give it something totally new, something it has no example for? That was the big hang-up. It would basically panic. It was a good idea, but it was really just a stepping stone to something way more powerful. The real game changer was statistical machine translation, or SMT. This is the tech that powered a lot of the online translation tools you probably used for years. The big shift here was profound. Instead of just matching examples, SMT started thinking in terms of probability. It started asking, okay, out of all the possible ways to translate this, what is the most likely one? So think of it like this. SMT has two key parts. First, there's a translation model, which is like a huge dictionary of probabilities, giving all the possible word-for-word options. But then, and this is the secret sauce, it has a language model. That's like a grammar and fluency checker. Its job is to make sure the final sentence actually sounds like something a real person would say. The best translation was the one that got a high score from both models.
Now, SMT was a huge leap forward. It was way more adaptable and fluent than the old rule-based systems, but it had this classic flaw. Because it worked by translating little chunks and phrases at a time, it often struggled with the big picture. You'd get these sentences that felt, well, disjointed and grammatically clumsy. The flow just wasn't quite right.
So to fix that choppy, unnatural feeling, we needed something more than just clever statistics. We needed a totally new kind of intelligence, a system that could look at and understand the entire sentence all at once. And that brings us to the age of AI and what we call the neural leap. Neural machine translation, or NMT, completely changed the game. No more breaking sentences into little pieces. NMT uses a single, massive artificial brain, a neural network, to look at the entire sentence, soak up its full meaning and context, and then start generating the translation. It's a truly holistic approach, from start to finish. So how does it pull this off? Well, it sees relationships. Imagine a giant, complex map where every single word has a specific location. NMT understands that the word king is located near queen and royalty, but it's really far away from words like cabbage or motorcycle. By mapping out language this way, it learns the deep connections between words, context, and meaning all at the same time. The results are honestly stunningly fluent. The translations sound more natural than ever before. But NMT has this new, kind of bizarre weakness. It can sometimes hallucinate. That means it can produce a translation that sounds perfectly fluent, totally confident, and is completely and utterly wrong. It's the ultimate example of being confidently incorrect. So we've got these completely different approaches, right? From rigid rules all the way to these hallucinating neural networks. And that raises a really important question. How do we actually know which one is better? How do we measure quality? Well, that's where the evaluation process comes in. And just to be super clear here, what we're talking about now isn't another way to do translation. This is how we grade the translators. This is their report card. Researchers use these automated scores with cool names like Blue, so basically grade the machine's work. It's kind of like a teacher who has a perfect gold standard translation written by a human expert, and they're just checking to see how closely the machine's answer matches it. And this is absolutely vital for tracking progress and for figuring out where these incredibly complex systems still need to get better. And here it is, the whole journey on a single slide. You can see the clear trade-offs at every single stage. We started with those transparent but really brittle rule-based systems. Then we moved to the more adaptable but kind of clumsy statistical models. And that finally brought us to today's incredibly fluent but sometimes unreliable neural networks. So we've managed to teach machines to speak our languages with this incredible, almost human-like fluency. But as we've just seen, being able to speak isn't the same thing as actually understanding. And that leaves us with the next great challenge, the next frontier. How do we get from just mimicking language to truly comprehending it? That's the next chapter in this amazing story.